Good morning and welcome to the second session of the day for our Connected Aviation Intelligence two-day program. Our session today at 10:30 is entitled SmoothSky Real-Time Turbulence Data for Business Aviation. And this session will feature a presentation from SmartSky Network's Vice President of Digital Solutions, Brit, Wanick, and he is going to give an overview of the company's new real-time turbulence data service for business aviation, SmoothSky. Please submit questions throughout his presentation. We'll try to get as many of them answered after the session is over as possible. This will be made available on demand, and we'll make the slides available to you as well. So without any further delay, I'll now hand it over to Brit.
Thank you, Woodrow. Appreciate it. Good morning, everyone, and thanks for joining on this Wednesday, the 2nd of December in 2020, virtual and all. So appreciate everyone coming on board. Also like to thank Woodrow and Abigail for making this happen. And I'd be remiss as well not reaching out and saying a big thank you to the Turbulence Aware team at the International Air Transport Association, IATA. They've been instrumental in bringing this into the business aviation space and collaborating with us. They've made for great partners over the year, and we're really excited about the opportunity to bring this into aviation and make it a part of something that we can all benefit from. To start, I'd like to just kind of cover off a little bit on a bit of a story to really bring home what the importance of aviation having turbulence data, what it means to us essentially, and specifically in business aviation. This is kind of starting with the why, the Simon Sinek of the world, if you will. And the story here goes, and this is actual real imagery from a colleague of mine that took a trip this past year. You know, one technical pilot from a commercial aviation group described flying essentially as trying to navigate a maze blindfolded. Right, we block off a certain amount of the airspace. We give individuals some things to look out for and say, go off on your way and hope you make it from point A to point B. The challenge is that we believe the day is going to be much like you see up there in the left, clear skies, smooth flying. And what, in fact, we really find is something more akin to what we see there on the chart image, which is an ever-changing and very dynamic atmosphere that presents particular challenges to us throughout the day. In this case here, you can see that small red cell forming right below the aircraft. That cell actually expanded quite quickly, and they were forced to make some quick decisions to be able to fly safely on their way. Ended well, everyone made it safely to the ground, but it highlights the importance of being able to adapt to the dynamic conditions that happen in the airspace. And the goal there ideally is that you'd have a dynamic map with you, much like we have a Waze in the car today. And we know when we're going to come upon an accident and we can make adjustments. We need something similar in the airspace. And that begins with having objective data to be able to work with. And a key element of that objective data is real-time turbulence and the ability to display it in the cockpit so that we can take action and have that action be based on real-time objective observations that are occurring so that we can get from point A to point B safely. So that highlights some of the importance there. The statement I got from my colleague was, man, we really wish we had SmoothSky up and running. It would have really helped throughout the transit. And we hope that now becomes a reality through this new service that SmartSky is offering out into the business aviation space. So where did it all begin? How did we get here? And what's the starting point? It bears to discuss a little bit about the IATA Turbulence Aware program. The program itself was launched in 2018. Now it's up to about a participation rate of about 29 global airlines around the world that are contributing and participating in the program. It is a crowdsourced objective data source. So those reports come in from those commercial airlines that are reporting. But the reality is it doesn't just have to be commercial airlines, right? As we bring this into the business aviation space, we look forward to having business aircraft also contribute. And much like an impressionist painting, the more dots that you put onto the screen, the better it comes into focus over time and the better we understand the state of the atmosphere. As I mentioned earlier, it's very important as well that it be something that is objective And the data that's a part of the turbulence aware program is based on eddy dissipation rate, or energy dissipation rate, often referred to as EDR. It is objective. It's an aircraft independent point of data that is calculated. And it's actually becomes a universal measure of the instability of the atmosphere. It's been adopted by ICAO and others. And it allows us to have an objective sense that whether I'm a 737 or whether I'm a citation, I understand the state of the atmosphere and I can apply it to my flight and use it in a meaningful way. It's also valuable in the fact that you may be flying into an airport that you're not familiar with, but as long as there's at least one aircraft that's gone through that and have some information there that doesn't require you to rely on local knowledge or another subjective point to be able to make your decisions with. There's additional data that comes along with it as well in the reports from the Turbulence Aware program that include both winds aloft and temperature data. This is obviously very important for the commercial airlines and will be important to others in business aviation as we move forward as well. The last part I'd bring in is that it's obviously very timely. It's intended to be a real-time program to report on a regular periodicity. Those reports today are configurable, but it's typically between 15 and 20 minutes. There's at least one report from the aircraft in flight if there's no turbulence. In the events where turbulence is determined by the algorithm, it starts reporting at 1 minute intervals. There's obviously some delay in connectivity. Better the network, the faster the speed. We've run some real-time efforts with this last year on our own aircraft at SmartSky, and I can tell you that we were able to generate the data, process the algorithm, and put it onto a display in less than 5 minutes with our own aircraft, right? So it is real-time from that perspective, and it does allow you to make great decisions. So that's a bit about the program itself. How do you interact with it? How does it work with regard to SmartSky? Effectively, we have collaborated with IATA. They've done the heavy lifting of being able to collect it from the global consortium of aircraft that are producing it. They handle the collection of that data via ground. Essentially, they do some cleaning of the data as well to make sure that it removes any errors. They normalize that data into a usable format. And the other thing they do is they anonymize it as well to help protect the commercial airlines and provide the necessary privacy that's been asked for. That data is then passed over to what we call Skytelligence. Skytelligence is SmartSky's web platform for trusted information sharing in the aviation ecosystem. So in this case, the turbulence data that we offer through SmoothSky is one of several different data sources that we have and several different data exchange capabilities that we provide to aviation. That data is then taken in and provided out or outbound via several application programming interfaces. So our enrichment of it is to put it in a format that is most usable by the ecosystem of participants that we expect would need it. Everything from a pilot to a web developer to a dispatcher. So we've got several application interfaces that you can use that data from. And we push it out into the marketplace via a set of partners and service providers. It's been asked, why would we not just go ahead and produce our own application for it? And the short answer is that there's already quite a few out there today. So rather than reinvent the wheel, the best approach was to make sure that we provide it to you in a format that takes advantage of something that you already have, essentially, whether that be an application on an EFB or a chart planner or the like. And so that allows us then to deliver that turbulence data out to pilots, operation centers, managers, insurance providers, maintenance providers, et cetera, in a variety of formats. So if from that point moving forward, what are those services that I talked about and how do I interact with them? The software, it's a software-based service essentially offered through the cloud. So it is something that can be put into both a data center to a dispatch, if you will, an operations center, and then sent to the aircraft. It can also be routed through essentially an accessible web application viewer. And what that means essentially is if I have an iPad in the cockpit and some connectivity, I'm able to bring up a viewer directly. We have 7+ APIs today that range in format from just showing you simply where in the air the turbulence exists, all the way down to the level of being able to support putting in essentially a flight path with different waypoints, and then being able to determine where along that flight path reported turbulence has been noted by something that's flown there before. We have been asked the question, and we focus heavily on making sure it's available for business aviation, right? The question comes out, well, hey, this is all commercial aircraft. How do we know that it's actually something that's valuable to business aviation? And the reality is that it does cover the routes. We've had this looked at independently by several third parties that directly service business aviation. And we know that the coverage is more than sufficient for the various airports and the like that business aviation flies in and out of. We're also very keen on making sure that's interoperable, hence the approach with the software as a service, if you will. The better you have with regard to in-flight connectivity, the faster that we can provide updates and visualizations, but that may not always be the case. So we made sure that it was available across any network, essentially, or in the absence of one, just available via flight planners and the like, so that you can at least have some sense of what you're heading into, even for short flights, where it may be 1 to 2 hours of transit. And it's all available or becoming available through a set of partners. This, again, is to allow you to see those or be able to access the data through your existing set of applications and services without having to add much more to your equipment or your kit. So if I'm interested, how do I get started, right? What do I need to do, and what would this mean to me, and the benefits of being able to do it? And this is where we start to branch out into being able to understand how I can use the data and use the applications and services that SmartSky is providing through SmoothSky, right? We know that there's an existing set of electronic flight bags, there's data link, and there's a set of dispatch software that's available in the marketplace today. So starting up there in the far left, right? In this case, we have just the aircraft cockpit, but there's the green screen, essentially the flight management system there. And utilizing data link, we're able to provide a set of alerts. This would be an integration through your flight management system provider or the service provider for that. To be able to essentially push alerts that are correlated to your particular flight path. And if you have real-time connectivity throughout the flight, then you would be receiving those updates much like you would any other information or advisories that come into the cockpit there. The large IATA viewer there that you see in the middle of the screen, that's something that can be displayed directly on a tablet or an EFB or on some other mobile device that's in the cockpit. It's available to you on the ground or at any point that you might have connectivity back to the big I internet itself. It's available as a web service and a web application through that, essentially. And then as you look further down, you'll see that obviously there's a variety of charting and planning software and trajectory path management software that's available in the marketplace today. Several big names, I don't need to name them directly, all offer those types of services with overlays that are associated with weather, icing, etc. And the data that's available through the SmartSky APIs can be integrated into that to provide an additional overlay. So you'll be able to see both weather patterns as well as your flight trajectory in and out of an area. Interestingly enough, here you see the area there around Denver, relatively typical for turbulence, mostly due to the mountain wave that comes off of it, but it provides a great way for us to be able to demonstrate how the polygon, or essentially the area of turbulence, would look in relation to a particular flight path. We've also been able to normalize the data a little bit to still provide the same type of coloring and indication associated with what you might find with PIREPs, providing essentially everything from a light, moderate, all the way up through severe. In this case, though, we're actually basing it on the set of numbers that are in the category of EDR there that you see on the right, where you have essentially a mean, average, a minimum, and maximum within that particular polygon itself. I will note here as well, it doesn't require that you have in-flight connectivity, right? Ground to ground connection is required, meaning you have to have access to the internet in order to be able to use it for dispatch or pre-flight planning use, right? It is a web service that we offer. And certainly when you do move into the connected space and increasing levels of connectivity that we have, right, we get to do a lot more. We can now start to do things both in flight as well as continuously over time. And if you had a trajectory path management capability that we're able to pull in the turbulence data and make adjustments, it'd be a lot like Waze, right? There's an accident up ahead. In this case, there's turbulence up ahead on my planned path. It's now been reported. I want to make a change. It can provide alternatives to you to help provide a smooth ride throughout the event. Allows you to essentially take advantage of better planning and arrival times. So what do I get out of it if I'm able to actually make all this happen? Well, the first and foremost, I would say, is we're able to essentially bring safety to bear, right? Safety first is a key element here. One might ask, well, how do I know that's really the case? And I can tell you the same technical pilot that talked about navigating blind through a maze would go on to later say in the same presentation that they've effectively or virtually eliminated crew injuries related to turbulence ever since they started using the Turbulence Aware product from IATA. So there's real validation of that in the marketplace today. Others have definitely come out and said as well that they're able to support savings and an improved experience over time for both the pilots, the crew, and the passengers. They're able to plan better, take advantage of it, and really make it something that's valuable in their day-to-day operations over time. There are improved routing mechanisms that can be applied to be able to save on fuel costs. Certainly changes in elevation come at an expense. And so being at the right flight level is something that's very important. And sometimes it may not be the one that you expect. And so having real objective data to apply that is a core element of success there. And then lastly, right, we want to make sure that we have a great onboard experience. This is key and important for commercial airlines, but it's also important for those that are business aviation operators, right? Whether it be charter flights or, I joke, it's like, I don't want to spill my martini in the back, right? Make sure that things are level. I fly with my wife not all that often recently, but I can tell you that she's definitely a white knuckle flyer. And that extra added level of comfort is very important. And if I can provide any way to help smooth it out, then it's something that I want to make sure that I do. And this does provide for that better onboard experience, essentially, in planning for those activities over time. So in closing, briefly there, just talking about essentially the items that are associated with the benefits of SmoothSky and being able to achieve those benefits. It's available to you today through those various service providers that you have. And it's something that can help you improve both your safety as well as your efficiency in flight, as well as your user experience. I do see one question here that's come in over time asking about the coverage and the resolution associated with that. But before we get started, I'll turn it back over to Woodrow here. I think he's going to kick off the Q&A session, and we'll get some more questions in and get them answered.
Yes, we do have a few audience questions here. I'll just start with the first one. With the reports from commercial airlines, what is the coverage like for business aviation flight routes and airports? Is that
Sure,
really
great question,
useful?
and certainly one that we've encountered a couple of times now, right? For instance, people ask, well, I fly into Teterboro, and that's not JFK, it's not LaGuardia, right? So what does it actually look like? And so rather than SmartSky be the one that says, oh, it's great, we actually coordinated with IATA. We went out to a third-party service provider for business aviation and had them essentially map, if you will, the standard business aviation flight routes on both the East Coast, the West Coast, and cross-country to turbulence reporting over the last year that was at various different flight levels, everything from 0 to 5,000, 5 to 10, all the way up through flight level 400. And being able to look at that data and actually understand the coverage that was applied to it And the short answer to that is they came back and said it's more than sufficient to be able to address the flight coverage for typical business aviation routes that we see. Obviously, there's less coverage when you start to go across the pond, and there's a little bit less coverage, obviously, when you look at the global numbers as well, just because it's a big world out there. And the coverage is increasing over time, but it's not something that is ubiquitous yet. Which is one of the goals of the program, is to continue to expand, both from a commercial airline perspective, but also from a business aviation perspective, and allow business aviation to contribute data just the same. Hopefully. Yeah.
And another interesting question, just about the commercial aviation flights have been in a downturn this year, obviously because of the impact of COVID-19. How many reports of turbulence are there coming from commercial airliners? Is the volume of that data sufficient?
Yeah, good question. So this year obviously it's less than it has been in the past. At latest count, they were on track to do about 20 million reports this year from roughly 1,800 aircraft that are flying and reporting. That was about 65% of what it was in 2019. But the numbers obviously are increasing. So there's still sufficient coverage across the globe. When you look at the latest U.S. coverage maps as well in North America, and then the typical tracks across the Atlantic, those are still pretty well reported and flown upon. And so those numbers are probably closer to 80% of what the volumes were. We expect them to rebound much the same as the whole traveling industry does here in the next few years. So there's still quite a bit of sufficient coverage to be able to do it. And in many instances, you can imagine too, it only takes one aircraft and one report to be able to let you know not only where turbulence is, because it begins reporting on that per minute basis, but it's also where the turbulence may not be, right? So in the event that you have a null report, it still gives you indication that an aircraft flew through that spot and that turbulence wasn't reported. And so you have some indication that it's a safer area to fly within. There was a question to dovetail in here too around the coverage on the resolution. When we produce it, right, the resolution that we try to put into the areas is roughly 30 nautical miles, because there is some deference to the fact that turbulence does move, right? And we're not trying to provide a new forecasted element of it. We're trying to give a report of the area in which it occurred. The reports themselves, though, are very specific to a particular latitude and longitude and altitude, right? So there's several different elements that are reported on. I mentioned the temperature and the wind data at that time, but it is a specific point in time in a specific spot, essentially by latitude and longitude, that report occurs. And so we then aggregate that and enrich that data to provide effectively we call it a polygon, but it's really a block of air that needs to be avoided. And that block of air can be described mathematically, and then that block of air can be included in a trajectory path management tool to be able to show you a path around it, or you simply can just avoid it on the chart by looking at the overlay and flying around it.
And we do have one additional question. So if you do have any other questions, please submit them now. This other question says, there's a big difference between turbulence for a 777 airliner and a citation or mid-size business jet and the accelerometer readings. How is that accounted for by SmoothSky?
Sure. So SmoothSky is thankfully we're the benefactor of the choice of the algorithm that they're using, which is the EDR algorithm. And there are a couple different ones that have come out over time. I would tell you that we're using the latest version, which actually isn't based on the accelerometer readings that may differ between aircraft, right? It's actually based on essentially the angle of attack and the parameters of the airspace itself, right? And so as a result, we calculate a value that is normalized for the turbulent nature of the atmosphere. And it's true that a 2-foot wave on the ocean doesn't look like all that much to an aircraft carrier, aka the 777, but to a John boat, it certainly does, right? And so you have a difference there where you do need to understand your aircraft. We do know that some service providers have also taken the input and applied a essentially a normalization to it that accounts for the type of aircraft that you have, right? So the average aircraft weight class can be applied to essentially moderate, if you will, those values. But you're always beginning with a very standardized objective value. And so you, as a pilot of the citation, know that when you see a 0.3, you know what 0.3 means to you. Just like a 2-foot wave to a John boat, they know what that means to them. But if I'm the captain of the aircraft carrier, I'm willing to fly through it. So the pilot is still able to make their determination of what they consider to be the objective nature of the state of the air versus subjective upon subjective, right? So you're making that decision based on a data point that you know is consistently applied. And that's the benefit of what we provide through the SmoothSky service.
Right. And I think that's going to be a good point to leave off at. Certainly some great information here about real-time turbulence data and what SmartSky is providing to the business aviation market. I want to thank SmartSky Networks for sponsoring this event, and thanks, Brit, for joining us for this session today. So we'll close it out there. Our next session will start at 11:30 a.m. We'll have a virtual keynote from NVIDIA. Thanks again for tuning in to this session.
Thanks so much, everybody. Appreciate the time.